Hi, welcome back to my channel. My name is Gina. In this video, let's talk about the elementary row operations, which are operations we can do on a matrix to help us solve a system of equations. Let's start with a form that we are more used to it. So here I have two equations with two unknowns. First equation is 3x minus y equals to 1. The second equation is x plus 2y equals to 5. Last week, we've looked at the matrix multiplication. If you haven't watched the video, I'll also put the link up there. So we can also write this system of equations into matrix multiplication. We can write the coefficient matrix 3, -1, 1, and 2 times a column vector of the variables x and y. And this equals to 1 and 5, the solution vector. You can use the matrix multiplication that we talked about in the last video. On the left-hand side, you'll see that left-hand side would equals to the left-hand side of the two equations. We can also write this matrix in augmented matrix form. That is, we have the coefficient matrix on the left, 3, -1, 1, and 2, with a vertical bar. So this vertical bar includes the variable column and the equal sign. So on the right of the vertical bar, we are going to write down the solution vector, 1 and 5. So this is called the augmented matrix form. But before we look at the matrix, let's solve the system of equations using the way that we are more used to it. So first of all, we can do equation 1 exchange with equation 2. Then these two equations becomes x plus 2y equals to 5 and 3x minus y equals to 1. And let's call this equation 3 and this equation 4. Then to solve for the unknowns, we will want to eliminate one of the variable. For example, if I would like to eliminate this 3x, then I can replace equation 4 by equation 4 minus 3 times equation 3. 3 times equation 3 is 3x plus 6y equals to 15. So the system of equation becomes x plus 2y equals to 5. The first equation remains the same, but we are going to replace the second equation by the fourth equation minus 3 times the third equation. That is 0x, then minus y and minus 6y. That is minus 7y. On the right hand side, we have 1 minus 15. That is negative 14. Let's call them equation 5 and equation 6. Then in equation 6, I only have one unknown, so I can solve for y. To solve for y, I'm going to replace equation 6 by negative 1/7 of equation 6. Then the system becomes x plus 2y equals to 5. This remains the same. And the other equation is now 0x plus y equals to 2. And this is equation 7 and equation 8. Now I already have the y, so I can use the 8th equation to help me to eliminate this 2y in the 7th equation. So I'm going to replace the 7th equation by 7th equation minus 2 times the 8th equation. 2 times the 8th equation is 2y equals to 4. So the system of equation becomes x plus 2y minus 2y, that is 0y. And right hand side is 5 minus 4, that is 1. And the other equation remains the same. 0x plus y equals to 2. And that is equation 9 and equation 10. So now we solve the system. The solution is x equals to 1 and y equals to 2. If you write the system of equation in matrix form, Then what are the steps that we just did in terms of matrix? The first step, we interchange two equations. If we write them in terms of a matrix, that would be interchanging two rows of a matrix. Notation for that is a row, let's call it row I, interchange, so we use double-sided arrow, and we interchange with another row, let's call it row J. Another operation that we did is we can multiply an equation by a non-zero scalar. In terms of a matrix, we can multiply a row of a matrix by a non-zero number. And notation for that is we are going to replace a row, for example row I, by a scalar times the same row, row I. Another operation that we did is we can add a multiple of the other equation to the equation. In terms of matrix, we can add a multiple of one row of a matrix to a different row of that matrix. Notation for that is we are going to replace a row, row I, by the same row plus a scalar times another row, row J. Now let's look at the same system of equation, but we are going to write it in matrix form. And we are going to use these three element row operations to help us to solve for the system of equation. I mentioned that we can write a system of equation in augmented matrix form. Now let's start with this form. The first step we did is to interchange equation 1 with equation 2. Then in terms of matrix, we are going to exchange row 1 with row 2. Then the matrix becomes 1, 2, a vertical bar, and 5. Then the second row is 3, -1, and 1. Then the second step we did is we will want to eliminate this 3. And we replace equation 4 by equation 4 minus 3 times equation 3. In terms of matrix, we are going to replace the second row by second row minus 3 times the first row. Then the matrix becomes, the first row remains the same, 1, 2, and 5. The second row would be 0, since we have 3 minus 3 times 1. Second element is -1 minus 3 times 2, that is -7. And on the right, we have 1 minus 3 times 5, that is -14. Then in the next step, we will want to turn this -7 into 1. So we replace equation 6 by -1/7 of equation 6. In terms of matrix, it will be row 2 is replaced by 1/7 of row 2. Then the matrix becomes 1, 2, and 5. The first row remains the same, and the second row becomes 0, 1, and 2. Then the next step is we will want to eliminate this 2. So we did row 1 is replaced by row 1 minus 2 times row 2. Then the matrix becomes 1, 0, and 1. And the second row remains the same, 0, 1, and 2. And since in matrix form, the column represents the variables, so the first column represents x, the second column represents y, and on the right is the solution. So here we also get x equals to 1 and y equals to 2 from the second row. So a quick summary. In this video, we look at the elementary row operations. The first type of operation is that we can interchange two rows. The second type of operation is we can replace a row by a multiple of itself. And the third operation is we can add a multiple of another row to the row that we would like to replace. If you have any questions, feel free to comment below. If you like my videos, please like and subscribe, and I'll see you in the next video.